Okay, so we're going to match these to the from the right to the what they are on the left. So if you look at translation, remember translation is just moving something left or right or up or down, and so you're adding or subtracting from x and y. It can be different numbers to x and y, it can be just to x or just to y, but that would be adding or subtracting, so that would go there. A dilation is when we either make something bigger or make something smaller, and we'd have to multiply x and y by the same number. So dilation's here, but if you look at the next one, it is divided by 2. That is just like multiplying by 1/2, so it's the same thing. A rotation is when we flip that x and y around. A reflection is when you make x or y negative, or it could be both. So reflections here, and then a stretch is when we multiply x and y by different things. So in this case, since we're multiplying x by something bigger than we're multiplying by y, this would be a horizontal stretch. And the next question was, which type of symmetry does this rectangle have? And this is if I rotate it around. If I rotate it 90 degrees, it looks like that. Well, if I rotate it 180 degrees, this is going to look just like it started. So it's 180 rotational. If we have to explain how these are congruent, remember, for them to be congruent, we have to have a rigid transformation that takes one to the other. That's those translation, rotation, reflection. So translation won't do this because it will still look like this if I move it left, right, up, or down. A reflection won't do that because it just looks like itself, or it stays in the same spot. But this would be a rotation. If my center of rotation is here, it'd be a rotation. And it takes one to the other. This one asks, what is the angle of rotation that maps point A to point B? Of course, I forgot to put point A and point B here, but let's just say point A, point B. And I didn't say which way rotation, so if we just do this way. So first of all, we got to figure out how many angles there are, because we know all the way around is 360 degrees. Well, this is broken up into angles, and there's 8 angles. So we would take 360 and divide it by 8, and we get 45 degrees. Well, from A to B, we're using 7 of those angles. So we would take 45 times 7, and we get 350 degrees. On this one, it says, how can we prove the triangle TAB is congruent to triangle CAB? Well, for congruency, we would have to have side, 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 or angle, side, angle, or side, angle, side. Those are the 3s we're looking at. There's another one called hypotenuse leg, but we're not worried about that one because these are not, they don't say they're right angles. So in this question, they'll give you some choices. So it's a multiple choice question. And in each multiple choice, they'll give you, like, this angle is congruent to this angle, or this side's congruent to this side. And we have to then see if it would make one of these. Now, we know that AB is congruent to AB because it's the same side. So we automatically have one of these sides. Okay, I don't know which one, or if we have more than one angle, but I want you to be careful because sometimes they'll say, like, angle B is congruent to angle C. Well, that is not in the same spot, so they're not corresponding angles, so it doesn't matter that it wouldn't make one of these. So be very careful of that. And then also, they may give you something where it's angle side side and not side angle side. That angle is not between those two sides, and this does not work unless it's a right triangle, and this is not a right triangle. Okay, let's move on to this one. What construction is being shown? This is not a completed construction, but there's only one little step left. And so this would be an angle bisector. Bisecting that angle. Okay, next one is we have these two triangles. And if you look closely, here is a triangle and here is a triangle. Be very careful. This is not a triangle. And sometimes we want to use those parts, but they're not. It's not a triangle. So we're going to go ahead and see what it's asking. It's saying, hey, if this is parallel to this, and here's some sides, and it says, what is the length of AD? So we want this length, but we're going to put in what we have, what they're giving us. So it says AB is parallel to EC, so we're going to make those. And if those two sides are parallel to each other, that means those triangles that I drew out just a while ago are similar. They're not congruent, they're similar. We know they're not congruent, they're not the same size. So let's put the things in we know. AB is 10, EC is 3, AE is 8. And we want AD, okay? So remember, 8 is a side of this part that is not a triangle. We would need to know what that whole part is. And if ED was like 3, you would add 8 plus 3, and it'd be, that whole side would be 11. But we don't know what ED is. So we're going to name it X. And if we still would add that to get that whole side. Okay? So, because it is similar, we would set up a proportion. You can write that down. Anytime you have similar triangles, you set up a proportion. So we're going to set up a proportion with our sides. So if I said AB, the corresponding side to AB in the little triangle is CE. Okay, and then I don't know any of this part, so I'm not going to use those sides. Okay, so I'm going to use the other side. My big triangle, because we have big on top on this fraction, we have to do our big part on top on the other fraction. So our big part is AD. And the small part is ED. Remember, AE is not a side of a triangle. That's a quadrilateral. All right, so now we're going to put in the numbers we have. So AB is 10. CE is 3. AD is X plus 8. It is okay to have some X's in here. And ED is X. When you have your fractions filled out, you are going to cross multiply. So 10 times X gives you 10X. And 3 times X plus 8, you're going to have to distribute. So 3 times X is 3X. 3 times 8 is 24. Now you have a middle school problem. You're just solving for X. So we're going to subtract 3X. You get 7X. And 24 is left over. And then you're going to divide this. So 24 divided by 7 gives you about 3.4. And we're not looking for X. We're looking for AD. And AD is X plus 8. So we're going to go 3.4 plus 8. And that gives us 11.4. And that is what AD is. In this problem, we have a large triangle. And we have a small triangle that is 2/3 of that. That's a dilation of 2/3. It said, how would triangle DCB be the image of triangle DAC? So BCD is our small one, okay? And because it's the image, it means it's the second shape. Pre-image is first. So our large one would be the pre-image. But we did a couple of things. We know that these are not congruent. They are not congruent. Okay? We said that. They are similar. Okay? And if I did a rotation 90 degrees clockwise after the dilation, it would land where triangle DCB is. Now, in this problem, it'll be a drag and drop, and it may not be 90 degree. I mean, it may not be a clockwise rotation, so you'd have to look and see which ones they offer. Okay, we're going to talk about these. These are similar. So there's a couple of things you can prove that triangles are similar, but we know if I have two angles that are similar in a triangle, that are congruent in the triangle, it makes those triangles similar because the thirds automatically. So let's see if we have two angles. Well, right here and right here, we know those are similar because they're both, congruent because they're both 90 degrees. And then we have another pair of angles that are congruent. They're not marked, and we don't want to say angle C because we've got 4 angles coming off of C. All right, so we need to name them. Angle ACB is congruent. And if I started with A, the one that wasn't marked, I have to start with E on the next one. So angle ECD. C's in the middle always, okay? And B is in the same spot because, look, they're congruent there. And what type of angles are these? These are vertical angles. So now I've found 2 angles that are congruent, which then gives me the angle-angle similarity. If I'm looking carefully at this one, I know these are similar, and we said just a minute ago that we could set up a proportion if they are similar triangles. So at first glance, we're going to look at this side. That is BC. So I'm going to look in the name of the second triangle, and where are those letters? Right there. They're in the same spot, so that's EF. So I'm going to go X over 9. And the only side left on this one that we know is 6, which is AB. That's the first 2 letters. So the first 2 letters on this one is DE. So we go 6 over 8. Don't flip these around unless you do both of them. We could have done 9 over X and 8 over 6. But you can't do X over 9 and 8 over 6. It has to be both the same way. So now we're going to multiply these. X times 8 and 9 times 6. And then you're going to divide that. Now, if they wanted you to answer it as a fraction, you can leave it like that, but then reduce it. So you can reduce it on your calculator. I know that 2 will go into both of these, 27 and 4, and that doesn't reduce anymore. So sometimes they want you to leave it as a fraction. All right, here we go. Billy wants to find the height of the tree. Billy is 2.5 meters tall. He stands 4 meters from the tree, and his shadow is 5 meters long. Find the height of the tree. Well, first, I forgot to put the sun, so you need a sun. It's important, just so you know which way the shadows go. So we don't know anything about the tree, so the tree is X meters tall. Billy is 2.5 meters tall, so I'm going to say Billy's 2.5 meters tall. He stands 4 meters from the tree, so this length right here is 4. And his shadow is 5 meters long. If the sun's on this side, the shadow is going to be on this side, and that is 5. And then we can make that triangle. We have our large triangle, and we have our small triangle. Okay, so says find the height of the tree. Well, actually on this problem, they're not really asking for the height of the tree, because it'll say, how do you set up the proportion or something to find the height of the tree? And they're going to give you about 5 different ones, and it better be set up correctly. So let's go ahead and set it up. Let's look at this side of the triangle. Remember, this is not a triangle, so this is not a side of a triangle. But if I add 4 and 5 together, I get 9. Like the tree's shadow is 9 over Billy's shadow. In fact, if you want to write this down, and then we're going to use the tree on top on the next one. So X is the tree over 2.5, and that is Billy. And that would be how to set it up. Now, just like I said on the last problem, if I flip this around, if I do 5 over 9, it has to equal 2.5 over X. Okay, so if I flip one, I have to flip the other. Also, I can swap sides. I can put X over 2.5 equals 9 over 5. It's okay to do that too. All right, determine the ratios, not a ratio, equivalent to the sine of f and cosine of f. So if you remember, when we're doing trig, we cannot find trig ratios of the 90 degrees, so that is out. All right, it's going to be the other two angles. And these are similar, which means all my angles are the same. So F and B are the same angle because they're in the same spot. And E and A are the same angle. And C and G, but we don't need those. So a while back when we were doing trig, we said, hey, the sine of one angle equals the cosine of the other angle in that triangle. Okay? So if I said, since F and B are the same, the sine of F could also be the same as the sine of B. And since F and E are the same and A and E are the same, the sine of F could also be the cosine of A. And then it says, do the cosine of F. We're going to just change all those around then. Cosine of F equals sine of E. Cosine of F equals cosine of B. And then the cosine of F equals the sine of A. In this next problem, it says use the above triangles if angle A is 38 degrees and angle E is also 38. Remember, because they're the same, right? They're the same angle. They're similar triangles, same angles. Then how would the cosine of both angles be the same even if the ratios are different? So remember, if I'm looking at angle A here and I'm looking at cosine, that's adjacent over hypotenuse. So my adjacent is 12, my hypotenuse is 13. So the cosine of A equals 12 over 13. But look at this smaller triangle. This side is not going to be 12 and this side's not going to be 13. It's a smaller triangle. But they are similar. Okay? So the angles are still 38. So here's the sentence you would write. I'm not going to write it out. I want you to write it. The cosine of 38, is equal to the cosine of 38 no matter the ratio or no matter the sides of the triangle. Okay, cosine of A is equal to the cosine of E. A is 38, E is 38. That's why they're the same. No matter how many times you push in cosine of 38 in your calculator, you're going to get the same answer. No matter what size the triangle is, the angle is the same. All right, here we go. This goes along with our trig a little bit. Here is alpha. That's what that means. This one means beta. Just like we used this one that was theta. They're just placeholders like X, Y, and Z. But when we use trig, a lot of times they use these Greek alphabets. Okay? So it's just using the triangle below. Let's give equivalent trig ratio. So we're going to do the same kind of thing that we did up at the top of that page. So the sine of B equals the cosine of A. And the cosine of B equals the sine of A. So one more thing I want to add to this is all three angles in a triangle equals 180 degrees. If we're using right triangles, because we're doing right triangle trig, we're taking 90 out. So 180 minus 90 leaves you with 90. Okay? Whatever this is, I subtract it from 90 to get this. So you may see something like this. The sine of B equals the cosine, and instead of alpha, they may say 90 minus b, because that's how you get the alpha. Okay, if you know what beta is, subtract it from 90 to get alpha. It may be something like that, but hey, look, these have to match when you do that. So I could say the cosine of, I could say the sine of A is equal to the sine of alpha is equal to the cosine of 90 minus alpha. They have to match in that case. Okay. It says, what is the measure of theta? So remember, when we're looking for an angle, we're going to use our second button on our calculator. Okay. Also, something you may want to write on your paper is this. This means the sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So in case you've never learned that, never heard it, no matter if I said it 15 million times, you have it now. Write it down. Okay, so I'm looking for the angle. I got to see what ratio I have. So this is my hypotenuse. And if I have to cross over there, this is my opposite. So I'm going to be using the sine. So opposite over hypotenuse. Yes, it can reduce. Do we have to? No, we're just going to put it in our calculator. But when we don't have what our degree is, we're going to do this, called the arc sign, okay? It's not an equal sign. And you're going to put in your calculator the second button. Then you're going to hit the sine button. Then you hit 4 divided by 12. So I'm putting it in parentheses, equals. And you get about 19.5 degrees. So that's what that angle would be. All right. Ted is lying on the ground looking at the top of a flagpole. Why is he lying on the ground? Well, that keeps us from having to have extra stuff there. So he's laying right here. So there's no extra room up there, okay? So the angle of elevation to the top of the flagpole is 30 degrees. We already have it labeled. What is the height of the flagpole if the distance from his eyes at ground to the base of the flagpole is 50? So we already have this labeled. We're looking for this side. So we're going to use this again, but we are not going to use our second sign because we have the angle. So we have to cross over. We have to figure out what sides we have. So we're crossing over. So we have our opposite. And this is not the hypotenuse. This is our adjacent. So we're going to use a tangent. So tangent of 30 degrees equals our opposite over our adjacent. And our adjacent is 50. And I put 50 degrees, but that's not 50 degrees. That's 50 feet. All right, so now I'm solving for x. So if x is on top, all I have to do is bring this over. So in our calculator, I'm going to go 50 times tangent of 30 equals, and I get about 28.9 feet. All right, let's talk about this. Let's go ahead and just label things that we don't know. All right, so I know that this is a central angle and it's 95 degrees, which then makes this arc to be 95 degrees. Then if you half it, you get what the central angle is, which is 47.5 degrees. Okay, so that's how you would find those arcs. All right, it says, is AB a diameter? Well, this is our central angle right here, which means it's half of the arc that it makes. It makes this arc. So if this is 90 degrees, double it. So 90 times 2, which then is 180 degrees. What do we know in a circle that's 180 degrees? What's a semicircle? And for you to have a semicircle, this has to be the diameter. So AB is the diameter. Okay, there's another one where I split the question to the next page. Okay, so this one says, how do we know that angle ACE is a right angle? ACE. Okay, if it is, I'm going to go ahead and mark it. Well, it looks like this line, line DE, is a tangent, or tangent to the circle, which means it touches it in one point where that is C, okay? And the thing we know about a tangent line and the radius, if it touches it at the point of tangency, which it does, is that they make a 90-degree angle. So a radius and the tangent line at the point of tangency makes 90 degrees. All right, this one says the length of arc DE and BC. What do we know about those? So let's look at this radius. The radius, and these are called concentric circles. They share the same center, okay? The radius of this is 4, and the radius of this larger one is 4 plus 4, which is 8. So this circle is like half the size as that larger circle. So arc BC is half of arc DE. If the circle's half, so is the arc, if it's cut with the same things. All right, let's look at this one. If I have 5 here as my radius, I want to know the area of the sector. And here's how I'm going to find the area of the sector. So go ahead and write this down. So I have to have what the degrees is of the central angle and my radius. I have those things. So it would be 40 divided by 360 times pi times 5 squared. So 5 squared is 25. So this would be, and I'm just going to go ahead and mark that out, 25 pi. And I'm going to leave pi. So I'm going to go 40 times 25 divided by 360. 40 times 25, which is, I haven't even done it, I'm sorry. 40 times 25 is 1,000 divided by 360. And there'd be pi behind it, or you can put pi up here, it doesn't matter. And then you would reduce this, or you could find the decimal of it. That's easy. Just put it in your calculator. It could be 100 over 36 pi. You could still reduce that even further to be, the 4 both goes into it, so 25 pi over 9. That's probably as simple it gets. So there's your answer. All right, last one here. We're going to change some values here. I just used the same circle. So let's call this theta. We still have 5 as our radius here. And it says, find the arc length. No. Find theta in radians. Remember, radians is a different way to measure degrees. Also, I have the arc length is 8.2. That is not degrees. It's a length, okay? So here's how you are going to write this. So write this down exactly. So we want to find it in radians. So what we're going to do is we're going to say this. Radians over 2 pi. Instead of 360 all the way around the circle in radians is 2 pi. It's something we did in Unit 7. And then 2 pi r. Okay, so because the arc length has to do with the circumference, and that's 2 pi r, not pi r squared. All right, we're going to plug in what we have. We don't have what the radians, but we do have what the arc length is. And this should be not area, length, okay? And so we don't have the radians. We have our diameter, which is 5, so 2 times 5 is 10. And we're going to do some multiplying here. And we're going to go 10 pi radians over 2 pi. So pi's cancel out. 10 divided by 2 is 5. And then you're going to take 5 away from radians because this is what we're looking for, okay? And we're going to divide it over here. And then you get 1.64 is what the radians are. And that's it. That's our last thing on this review.